Yes. Okay, so we are going to talk about geometric distribution. Why do we use it? So we will start like, let's suppose that you have a dice and you are rolling it, and you will roll it again and six. And we don't know that when we will get that six, when that six will appear. Maybe it's possible that you roll the dice and you get a six on the first attempt. Maybe you keep on rolling it and you don't get a six until on the 10th turn. But one thing is certain, that we will stop when we will get the 6, because we are just only looking for the 6. For us, being successful means, in this case, being successful means getting a 6 on a rolling dice. So one thing is for sure, that we will stop when we will get the first 6, but we don't know that at after how many attempts we will get that six. So what we are actually doing here, are we like get counting the result of the roll, or are we counting the number of attempts that it will take to find the first success or to get the first six? What we are actually
We're
doing here.
counting the number of attempts.
Very good. So we are actually counting the number of attempts it will take to get the first success. Being like referring to success means that getting a 6 on the dice. So we will count the number of attempts that it will take to get the first 6 on a rolling dice. So we can see that we can use geometric distribution like other examples, such scenarios where we count the number of attempts before getting a success, is maybe you are finding the number of days until you get a first rainy day, or maybe you are looking for the number of trials until a machine fails, or maybe number of throws until you score, and many other examples like this. Maybe you are finding the number of emails that are checked until you get the first error. So in all these type of situations, we use the geometric distribution. So geometric distribution is actually used where you want to find how many attempts will it take to get the first success. And with success means the criteria which I will define, the event
Mhm.
that I am looking for. That event is I will be the success for me. So before moving forward, before going into any formula or any examples, first you need to know that there are two possibilities for every attempt. You may get a success and you may get a failure. In case of rolling a dice until you get a 6, what will be the success for me? If I get a 6, then that will be a success. And if I get
Mhm.
any other number on the dice except the 6, then that will be considered as the failures. So success is actually the event we are looking for, and failure is everything else.
Mm.
So we have these two things, and we know that every trial, or every time we will roll the dice, we will have two possible outcomes. Either it will be a success and either it will be a failure. Now, if we take a little bit complex example so that we can understand it, let's say now if I say that we have two dice and I throw them, so what will be the probability of getting a total of 10 or more? Now, if you look at this, you see that you have two dice and we want to find the probability of getting. P represents the probability for getting a total of 10. Total of 10 means the sum of the results that you will get on both the dices.
Mm.
Uh, so what will be the probability that you will get a total of 10 or more than 10? What is the maximum that I can get from two dices? What's the
Mm.
maximum or the largest number that we can get?
12.
Yes, very good. So we can have three options that you can get a 10, a 11 or a 12. These are the three possibilities, right? Because we
Mm.
are looking for the probability for getting a total of 10 or more. So it can be a 10, a 11, or a 12. So let's say if I get a 10, what are the possible pairs possible pair of numbers that I will get on both the dices? It's a possible that on the first dice I get a 4 and on the second I get a 6. It's
And six
possible.
four.
Very good. And
Seven. No, no, wait. What else?
a 5 5.
Mm.
So these are the three possibilities or the three combinations that can give me the 10, a total of a 10. But in the question, it is asking us the probability for 10, 11, and 12, all of them. Now we will look for the 11. What are the possible combinations that can occur for getting a total of 11?
5 and 6, and 6 and 5.
Yes, very good. So it will be 5 and 6, and then 6 and 5. And then for the last one, which is 12, we have,
6 and 6.
yes, very good. So if I get any of these six combinations, 1, 2, 3, 4, 5, 6, it will be a success for me, because I have defined the success as a total. If I get a total of 10 or more than 10, then that event will be considered as a success for me. So all of these 1, 2, 3, 4, 5, 6, all of these six events are the success for me. So the total favorable outcomes for me are, how many events do I have as the favorable outcomes, or the
Uh,
events that you can consider as the success? Let's say I roll the dice, I get a 4 and 6. Will it be a success for me? Yes, because I'm
yeah.
getting a total of 10. If I get a 6 and a 4, it will also be a success for me. If I get a 5 and 5, it will also be a favorable outcome, or success are the same terms. If I use the term favorable outcome, or if I say that success, it is the same thing. So favorable outcome is obviously the success for us. So it's like favorable outcome and success. So if you are looking for a total of 10 or more, how many favorable outcomes do we have? We just figured it out. For 10,
6 of them?
we have 3. Sorry.
6.
Yes. For 10, we have 3. For 11, we have 2. And for 12, we have only 1. But it has not limited the outcome to only 10 or 11 or 12. It has just generalized it by saying that you get a total of 10 or more. So you will consider the favorable outcomes for 10, 11, and 12, all of them. So the
Mm.
total favorable outcomes will become 6 in this case. So I will write the favorable F out. FO means favorable outcomes. So we have 6 favorable outcomes in here. And what are the total number of outcomes that are possible? If I have two dice and I roll them, I throw them on the table, how many possible outcomes can I get? Possible number of outcomes. Using the first dice, how many possible outcomes do we have if I have only one dice?
6.
6. Very good.
6 outcomes.
And
Oh, you mean in
yes,
total? Then it'll be 12 outcomes.
no, not 12.
In total.
Not, no, not
Oh,
12.
sorry, 36. 36.
Very good. Because for each number, let's say if I am considering only dice A right now, for its each number, let's say I get a 1 on dice A, I have 6 possibilities that with 1 on dice A, I can get 6 possible different numbers on dice B, right?
Mm.
So it means that 6 possibilities are from here and 6 numbers are possible from here. So you multiply them. So it means that the total outcomes will be, total possible outcomes, P O means possible outcomes are 36 when you are using two dices. So how do we find that? And we have calculated that the favorable outcomes are 6. So how can we find the probability for a success? We represent it as P. Probability for a success means that you will find that what is the probability that when you roll two dices, you will get a total of 10 or a 11 or a 12, like more than 10. So what is its probability? What are the chances? This is what probability means. That what are
Mm.
the chances that you will get a total of 10, 11 or a 12 when you roll two dices. So how do we find it out? The formula for it is favorable outcomes divided by the total number of outcomes or the possible outcomes. So we simply divide it. So if I divide it, I will get 6 divided by 36.
Mm.
So it will become equals to 1 by 6. So the probability is 1 by 6. It means, what does that mean? If I tell this in English or if I explain it, its meaning, it means that it's possible that if you attempt or if you throw the dice, the two dices 6 times, then there will be a chance that among the 6 throws that you have thrown, one will be a success. Like among the 6 tries, you will get one time a success. This is the
Mm.
probability or the percentage or the chance of having a success. Making sense?
Yeah.
Okay. And how do we write the probability of failure? We represent it as Q. And what's the failure for us in this given scenario? If we are looking for a total of 10 or more, what will be the failure for us then?
It'll be 1 minus 1 or 6, which should
Yes, but
be
like
5 or
no, but
6. Hmm?
I'm asking you the like in just to tell me the explanation. If getting a total of 10, 11 and 12 is a success for us, then what should be the total value that I will get from both the dices, which will that you can say that which I will consider as a failure for me. If
Like
I
all
get
the other numbers, you mean?
yes, so it means that if you get a sum of any other number from 1 to 9, 1 is obviously not possible, from 2 to 9, it will be a failure for us. This is what the failure does, and we represent it using the Q, and it is 1 minus P. So we simply subtract the chances of having a success from the total probability. The maximum probability is 1. If we have a probability of 1 for any success, it means that there is a 100% chance you will get successful. So
Mm.
we will subtract the probability for having the success from this. If you write it in the form of, let's say, you can say that if you write it in the percentages, maybe you get a probability of 0.0. No, let's say you get a probability of 0.30. In percentages, what does that mean? You multiply it by 100 so that you can see the results or the chance of having a successful event. You multiply it by 100, you will get, if you multiply it by 100, you will get 30, right? It means
Mm.
that there is a 30% chance that you will get successful. And subtracting it from 1 means that you are subtracting this 30% from 100%. So 100 minus 30 will give you 70. So it's obvious, it's logically obvious that if there is a 30% chance of being successful, then there is a 70% chance of being a failure.
Mm.
That's why we minus this probability for having a successful event from 1, and 1 means there is a 100% chance. 1 represents 100 if we are considering the probability in terms of percentages. So you subtracted 1 minus p. So it will become 1 minus 1 by 6 equals to 5 by 6. Clear until this point?
Yeah.
Okay. Now we will move forward and we see that in the book there was one example that Asha throws the dice repeatedly until she gets 10 or more. She succeeds on her sixth attempt. Okay, so it's written that repeatedly throws until she gets a 10 or more. So, what will be the success for us?
Uh,
The successful event. She gets 10
10 or
or more.
more. So it'll
Yes,
be 1 over
10.
6. Sorry.
Yes, the one that we
Yeah.
just calculated above. So the successful event is if she gets a total of 10, 11, or 12, then that event will be considered as a success. Otherwise, it will be a failure. So she keeps on throwing the dice or rolling the dice until she gets a 10 or more. But it is also mentioned that she succeeds on her sixth attempt.
Mm.
What does that mean? That the first five attempts were the failures. That's why it is written that she succeeds on the sixth attempt. She succeeds on sixth attempt. And we know that after the first successful attempt or after getting a first success, we stop there. So it means that this sixth attempt should be her or must be her first successful event. So that makes it obvious that the first five attempts were a failure. And the sixth one was a success. So if we want to write it symbolically, we can write it. If we represent the failure using the F symbol, and for success we use S. So we can represent it symbolically that first attempt was a failure, then it was again a failure, then it was again a failure, failure, then failure, and then success. Right? And we know
Mm.
that what was the probability of one failure? The Q that we just calculated. Q is the probability for one failure. What was the
Mm.
probability for the failure?
5 or 6.
5 by 6. Very good. And we know that we have five consecutive failures. So the probability of five consecutive failures is 5 by 6 multiply by 5 by 6 multiply by 5 by 6 multiply by 5 by 6 and multiply by 5 by 6. It means that you can write it as the probability of five consecutive failures. You can write it simply. You are multiplying 5 by 6 five times with itself. So you can write it as 5 by 6 raised to the power 5, right?
Mm.
Yes. So the probability of the five consecutive failures will be 5 by 6 raised to the power 5. And then on the sixth attempt, we got a success. So the probability of success on the sixth attempt, we can write it as probability x is equals to, what does this x represent? X represents the total number of attempts it will take until you get a first success,
Mm.
including that term as well, where you will get the success. She got the success on the sixth attempt, but we are counting that as well. So this represents the number of attempts until the first success. Okay, so it will become, how will we do it? If you are given that x is equals to 6, it means that it took 6 attempts until she got the first success. It means that the first five must be the failures. So you write it as 5 divided by 6. You simply multiply the probabilities that you get on each event and you multiply them. Let's say if you got a series like failure, failure and success. What do? You simply multiply the probabilities for each event. The probability for first failure will be 5 by 6. Then you will multiply the probability for the second event, which was also 5 by 6. Then you multiply with the probability for the third event, which is a success. So it will become like this. Over here, we got 5 consecutive this, failures. So it will be 5 by 6 raised to the power 5 and multiply it by 1 by 6.
Mm.
So you will get a total of approximately 0.067. If I ask you to tell me the probability in terms of percentage, what is the percentage chance or the probability for having a successful event in terms of percentages? How can you tell that? We just multiply it by 100. I told you that. So we will multiply it by 100. So what will we get? If I multiply it by 100,
It'll be 6.7%.
yes, very good. So it will be 6.7%. So it means that, what does that mean? That there is a 6.7% chance that she will get a success on her sixth attempt. After failing
Mm.
for the first 5 times, for the first 5 attempts, she will get successful at the sixth attempt. There is a 6.7% chance of this event, or
Mm.
you can say um, this series of events, that she will get 5 times she will fail, and on the sixth attempt she will get successful. So the chance is 6.7%, right?
Mm.
Okay, so if we move forward and we look at the conditions for using the geometric distribution, do you know the conditions? What are the
Mm.
conditions? The conditions for using the geometric distributions is, the first condition is that each trial will only have two outcomes. It will either be a success or a failure. So there are only like two outcomes. It will be either a success or a failure. Yes. And the second condition will be this, that the probability of success is constant. What does that mean? That the probability of success is constant. It means that the individual probability for any event is not changing. Let's say I have a single dice and I am looking for a 6. I in the first attempt, I have a probability of 1 by 6, right? There is a
Mm.
1 by 6% chance, like if you convert it, whatever you will get percentage, there is a 1 by 6% of a chance that you get a 6. If you try it for the second time, I'm talking about only the individual probability. On the second try, there will be still a 1 by 6% chance that you will get a 6 on second attempt. For considering the individual probability for only that particular event without thinking about anything else, the individual probability of any event is not changing. Let's say if you throw the dice on the first attempt, there is a 1 by 6% chance, because it's equally possible that you get any of the one numbers on the dices. On the second attempt, it will still be equally possible that you get any of the numbers on that are on the dice.
Mm.
So the individual probability of success is not changing, it's constant in every attempt. This is the second condition. The third conditions is you count the trials or the number of attempts until the first success. Then you stop after that. Count the trials until the first attempt, and then we have a last condition that says that the trials are independent of each other. Okay, so the trials are independent. So if we write the general formula for it, we know that P is the probability for success. How do we find Q? Q is 1 minus P. Obviously, if you subtract the chances for a success from the total probability, you will get the probability for the failure. So this is
Mm.
the probability for the failure, and the probability that the first success occurs on which event, we write it the general formula as P x is equals to R. Let's say if you are given that you will get the first probability on your rth term, it can be any number, we are generalizing it using R. So you will write it as, if you are getting your success on the rth number of attempt, it means that all the attempts before reaching to this rth attempt, they were all failures. It means that
Mm.
the starting r minus 1 times of attempts, they were all failures, right? So you will write
Mm.
it generally as q raised to the power 4 minus 1, because these all were the failures, and then you will multiply it with the last probability in which you will get the success. This is
Mm.
the general formula. So you will first fail, minus 1 times, and then you will succeed only once, and then they stop counting the trial. Very clear or not?
Yeah.
Okay. Okay, so it's also given that Gina knows that the probability of knocking over a coconut on any throw is 1 by 3. So the probability is given as 1 by 3. This is the probability of success for us. So using this, you need to find the probability that Gina knocks over a coconut for the first time on her fifth attempt. It means that you need to find what is the probability. It's written that you need to find the probability that Gina knocks over a coconut for the first time on her fifth attempt. It means that she is getting successful on her fifth attempt, right? The first four will be the failures. Making sense?
Yeah.
Yes. She is knocking over the coconut for the first time. For the first time means it is the success that she is having for the first time on her fifth attempt. So it means that the first four attempts were the failures. So using this probability for the success, we will calculate the probability for the failure. So we will write it as Q is equals to 1 minus 1 by 3, and we will get 2 by 3. And if we write it symbolically, just to see that what will be the series of events, the first four events were the failures. So they were like failure, 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 then again failure, and then we got a success on the fifth attempt. So if we write it as P, what is the value for X here? This X shows the number of attempts. So what is it?
It'll be
Is it 4
5.
or 5? Very good. It means you count the attempt where you get the success as well. So the probability is you will, for the first four failures, you will multiply them 2 by 3, multiply by 2 by 3, multiply by 2 by 3, and multiply by 2 by 3. So it will become 2 by 3 raised to the power 4, multiply by, for success, it was 1 by 3. So you will get 0.0658. So if I convert it into percentages, it means that there is a 6.5% chance that you get your first success on the fifth attempt.
Mm.
Okay. Okay.
Mm.
In its second part, it is asked that find the probability that it takes Gina at most 3 attempts. It is saying that you need to find the probability for at most 3 attempts. At most 3 attempts means that she may get successful on her first attempt. It's also possible that she get a success on her second attempt, and it's also possible that she gets successful on her third attempt, right? So
Mm.
all the three will be considered correct. We just need to find the probability that she may get successful in either in any of the first 3 attempts. So we can use two methods. The first method is simply the probability. You will find the probability that she gets successful on her first attempt. It's also possible then you will find the probability that she gets successful on her second attempt. This will be also considered correct, and then you find the probability that she gets successful on her third attempt, which is bx is equals to 3, and you add all the probabilities because all of them will be considered correct. If she gets successful on her first attempt, that event has some other probability, this has some other probability, and this has some other probabilities, but all of them will be
Mm.
considered correct according to the situation at most 3 attempts. So the total probability will be the sum of all these probabilities, which will be allowed in this given scenario. So you can find the individual probabilities for all these 3 events and you can add them, or but this method cannot work when you start dealing with too many large numbers. So we use
Mm.
another method, which is method 2. This was method 1, and we will be dealing with method 2. Okay, so how can we do that? It is saying that at most 3 attempts, she must be successful in at most 3 attempts. It means that she must not fail in all the first 3 attempts, right? She must
Mm.
get successful in any of the first 3 attempts. It means that not failing, this is the same thing said in two different ways. Not failing all first 3 attempts. Are these both correct? Are these both things the same or not? That she needs to get successful in at most 3 attempts. It means that she must not fail all of
Yes,
the
it's the
first three
same thing.
attempts. Yes, that's the same
Mm,
thing. Very good. So, how can we do that? We can do that. It is said that not she must not fail in all the first three attempts. So, what we can do, we can find the probability for failing in all the three attempts, and then we can
and then one
subtract it
minus.
from one. Yes, very good.
Yeah.
And when then we will subtract it from one, which is the total probability, and then we will get the probability for not failing all the first three attempts. Making sense to you?
Mm, yeah.
Okay, so we can write it as probability of at most three. This is the same thing that she needs to get successful in at most three attempts, or if I say that she must not fail all the first three attempts. So we can do 1 minus the probability that she fails in all the first three attempts. So fail first three attempts. Failing the first three attempts means that she got a failure, failure, and failure. So, what was the probability for the failure? It was 2 by 3. It means so you are
Mm,
multiplying 2 by 3, multiply by 2 by 3, and multiply by 2 by 3. You can write it as 2 by 3 over 3, like this. It's the same thing,
mm,
like this. So, you will substitute it into the formula. So, it will become equals to 1 minus 2 by 3 cube,
mm,
like this. So you will get 19 by 27. So if you convert it into percentages, then you can understand it better that there is a this much percent chance that she will get successful in at most three attempts. Like she can be successful in the first attempt, in the second one, or in the third one, but she will be successful in any of the first three attempts. At most, in the three attempts, she may get successful. There is a this
mm.
much percent chance. If you convert it into decimals and then multiply it by 100, you will get the percentage equivalence for this probability. Clear?
Yeah.
Okay. So if we move forward and we see a one more formula, that is, let's say if you are given a question like she what is the probability that she will not get successful in the first 10 attempts? It means
Mm,
that she will take more than 10 attempts to get successful, right?
mm,
So we use another formula for something like this. There will be questions where you will be given only the minimum number of failures. Just like I gave you an example, that you may be given that what is the probability that she will not get successful in the first 10 attempts. In this question, you are only given the number of failures. That in the first,
mm,
what is the probability that she will get failed 10 times in a row? So you are not told about anything about the failure or how much attempt she will take or she will need in order to get successful. The only thing that is mentioned or that will be given in the question will be the number of failures. So
mm.
in those type of questions, you use the formula like the probability of taking more than R trials. It can be any number, so I am representing it as R. Okay, so let's say if you are given in the question that what is the probability that she will not succeed in the first 10 attempts. So it means that she will take more than 10 attempts in order to get successful, right? So we know
Mm.
that the probability and what is the r, what will be the value for x here? It will be more than r
Greater
because
than or
yes, very good, because we know in the first r number of attempts she got only failures. So x will be greater than r, and we write it as the probability. It means that if she is getting the successful after r number of trials, it means that the first r number of trials were the failures, right?
mm,
If I say that what is the probability that she will not get successful in the first 10 attempts, it means that the first 10 attempts will be the failures. So we write that as the probability for the failure r times. What does that mean? That she got failure for 10 times. Like there were f or the failures 10 times in a row. So you are multiplying the probability for each failure, and
mm,
they will get a power of r, the total number of failures. And in the example that I just gave you above, its value is 10, right? So you write it like this, right?
mm.
Okay, so if we move forward and we see one more concept of mean of geometric distribution, how do we represent the mean?
1 over p.
And what does that mean?
It's basically a reciprocal of the
Yes, like,
success.
but the reciprocal of it, but what does it tell us? Like, what information does it give us?
Or it's like the average number of the successes.
No, it actually tells us that how long will you need to wait, or you can say that it is closely related to the average number of failures that you will have to see until
Mm,
or unless you get the first success. So it actually tells you that how long will you need to wait until you get your first success. So if you have a less probability for some event, then it means that I will write a smaller number in the denominator, right? Because the
mm,
probability is less, the number will be smaller. And if we divide by having a smaller number on in the denominator, we get a larger number. So
mm,
it means that if the probability of having an event is less, you will have to wait longer time. You will have to wait more because obviously its probability is less. So it's making
mm,
logical sense as well. So this EX, which is what we call the mean of geometric distribution, it actually tells you the average weight or the average number of failures, you can say.
mm,
Not exactly the average number of failures. So you can, to be more precise, you can say the average weight before having the first success. Okay. So if you have smaller probability for an event, if the p is less, you will have to wait longer. So e of x will be larger. And if the probability for an event is larger, then you will have to wait for the less time. So it will be smaller. They are reciprocal of each other. Okay. So if we take an example now, it is given in the question that 6% of messages contain an error and finding the error is the success for us. 6% of messages contain an error, and what's the success for us? Success is finding the error. So this 6% is actually the percentage of success or the probability for success. This one.
Mm.
Success is error and failure is everything else. So if I convert this percentage into the probability, how do we do that? If we are given the probability and we want
Divide
to
by
convert it,
100.
very good. If we want to convert to percentage, we multiply by 100. If we want to convert from percentage to back to probability, we divide by 100. So the
Mm.
probability for success is P
Zero
equals to,
point 0.06.
yes, very good. It will become 0.06. And what will be the probability for the failures? It is,
0.94.
yes, very good. So it will become 0.94. Okay, now you need to find in the first part, you need to find the probability that you will get the first error, which is the success for us, in your sixth message. So it means that you are getting your first success on the fifth attempt, on the fifth message. So the value for x will be 5. And what does that mean? If I am getting the success on the fifth attempt, the first four were the failures. So 0.94 raised to the power 4 multiply by 0.0606. So it will be equals to 0.0468. So it means that there is a 4.6% chance that you will get a error message on your fifth attempt.
Mm.
In the second part, you need to find the mean number of messages that you will have to face before your first error. It means that you need to tell the time that you will need to wait or the number of failures that you will have to face before you get your first error message or before you get your first success. So we write it as EX as 1 divided by 0.06, and it will become approximately equals to 16.7. So it means that according to the probability of the success, you will have to wait for about 16.7 messages. The first 16.7 messages, or if you round them off, the first 17 messages will be probably the failures for you, and you will get the error message on your 18th attempt on average. This tells us the average.
Mm.
So now in the next question, you need to find the probability that you don't get the error in your first 10 messages. No error in first 10 messages. So what is given in the question? Is the number of attempts for the first success mentioned in the question or not? The
Mm.
the number of attempts that it will take until you get your first success.
So
Are
x
they?
is greater than 10?
Yes, very good. Because they have only given us the number of attempts, which will be the failures.
Mm.
Definite number of attempts, that will be the failures, and we don't know that what will be the value for x. It can be anything greater than 10 because the first 10 will be the failures. So x will be greater than 10. So it will become, the probability for failure was 0.94, and we know that all these 10 attempts will be the failures. So
Mm.
failure multiply by failure 10 times. So 0.94 raised to the power 10. So it will be a 0.539. So it means that there is a 53.9% of chance that you won't get successful or you won't get your error message in the first 10 messages. So there is a very high percentage for the for facing a failure. Clear or
Mm.
not?
Yeah.
Okay. So let's just end. This was all about the geometric distribution, the general formulas. We have discussed all of them using different type of formation examples. So it was all. If you
Mm.
have any question, you can ask me. If you have any doubt about anything.
There was, I think, like one formula which I had a doubt in. Like, there's a different formula. Wait, I'll
Which one?
I'll check 1 second. No, I don't remember if I was in this chapter or not. But wait, 1 second.
The PDF that you shared with me, I guess it only had all of these things that we have discussed.
Yeah.
You shared a PDF, right?
Mm.
So it only consisted of these topics.
Oh, that was another chapter. Okay, yeah. No, I don't have any other doubt.
Okay. So is it clear?
Yes.
Okay. So let's end the class. Take care.
Okay. Allah Hafiz.
Allah Hafiz.